Alright, time for another DraftPhysics.com video presentation. So, the DIY people, do-it-yourself physics experiments, Dispar is analyzing a variety of these CART experiments that are online. And I've sort of made the accusation that all of these are not really scientific experiments. They are intended to demonstrate what their what their book says. All right, so they're being forced to produce an outcome. And so the last two examples he shows, there are obvious suspect aspects to the experiment that you can notice that make them suspect. So the idea is that you send a one mass, okay, with a velocity. Let's just say it's 2 for the sake of the argument. In this case, they're using magnets, so I'll draw that as this. Okay, repulsive magnets, which is a nice, elastic spring. You would argue, pretty conservative. And the idea is that this 2 mass, they claim, all right, will leave with 2/3 this velocity, which means it will gain, 33% more momentum. So it will increase the momentum of the crash. You'll hit this object, will have a certain momentum going into a collision, and somehow after the collision you'll have more momentum than you started with going this direction, and you'll even get a little bonus of some extra momentum going backwards. So you'll get 33% that way and 33% this way for a total of 66% increase in the momentum. So I argue that physical universe can't make free momentum, because momentum is in fact energy, and you just can't make free energy. If it was this easy, we'd all have one. We'd make our light bulbs twice as bright. We'll make our machines work twice as well by just adding some feature that causes a light thing to hit a heavy thing, because it's instant extra free energy. So obviously I would argue that this can only go 50% of the original velocity, and so it has to leave with a 1v, because you have to conserve the momentum. As Professor Lewin said, nature can deal with kinetic energy one way or the other. Nature can't finagle momentum. Well, if that's true, then this can't be true, and this can't be true, and this can't be true, and this has to be the fact. So anyway, so they keep producing experiments where they make this free momentum. All right, so let's look at the experimental data. Okay, these people who like experimental data and thinks it means something. Well, the argument is it only means something if you can trust the physicists. And the fact is, no, they're not in the game of doing physics. They're in the game of demonstrating physics, showing you their shroud of Turin, And so they're going to juice it any way they can. All right, so the first one he did, has this really bizarre little feature. So we'll play it, and I'll show you a couple of the bizarre little features. If I can get the right thing to highlight, which is this window. So I really need to make this monstrously big, unfortunately. But I think you can see that now. There's this funny little aberration. See these little green dots up here? They're not supposed to be there. Okay, so there's little green dots that are mimicking these dots right here. They're exact mimics of them up here on this line. And that happens when he scrolls the chart. Okay, so the idea is that this, I think, is just a manifestation of the software, where it's showing you something that went off the screen, and it's showing you on the screen. And then when you scroll it, you can see that the real marks are up higher. Okay, and then these lower marks, I can demonstrate that these velocities don't make any sense, because the two objects don't travel enough distance for this one to be going twice as fast. It has to be going 3 times as fast for the distance it covered. So these marks here just don't add up. All right, so I'll show that by playing the video. So I'd have to make it small again. Unfortunately, just the way the video is made, it's a little bit, you know, you don't get to see the experiment up close. All right, so I'll show you the scrolling of the screen thing, and I'll show you the real experiment. All right, that's enough. I think you can see enough of it there. So this little green line is the cart going in, the red line is the cart going out, and this is the reflection. And the blue cart will start here in the middle, okay, and it's going to go all the way to the end and bounce back. In the time the red cart barely goes a foot, you could argue. It's going to travel about a foot backwards, and it's going to stop. It's never even going to reach the end. It's going to run out of fuel so quickly that it won't even, it stops moving. So it only barely moves. Now the line they're showing is a pretty substantial line, and it's supposed to have a pretty good velocity, and you know, when it's pretty much stopped moving, they're still showing it as moving, which also doesn't make much sense. And he turns it off, is the fact. The fact is he hits the stop button before we get to see these reflections, unfortunately. But for the sake, you know, you'll see the scrolling part, so that's the important one. So let's do that first, and then you can look at the carts themselves. All right, so here's the blank screen, and we'll try to stop this. Okay, so there's the cart starting. Now you can see the dot goes right up to the top of the screen. He's going to have to scroll it later. And when he scrolls it, all of a sudden those little green lines show up at the top, meaning maybe this isn't exactly kosher. All right, now you can see the blue cart started here. Now the red cart is going to go to about here. So it's only going to gain, you know, whatever, a foot in real distance. And the other cart's going to go all the way to the end and bounce off a guy's finger. Okay, it's not even bouncing off a rubber band. It's bouncing off of a finger. All right, so now they're separating. You see the red cart is going pathetically slow, you know, in the sense that it's not gaining much ground. All right, and the blue cart's going to get all the way to the end and bounce back. In the time, the red cart doesn't even get more than a foot. So you can see it's almost to the end now, the blue cart. The red cart is barely gone, you know, 8 inches. And the blue cart's almost going to hit the end now. So there it is, and it bounces back. And the red cart is pretty much stopped. So this chart is crap. Okay, this isn't accurate. There's no way it's going this fast at that point because it's barely moving here. Barely moving. So let's understand, the blue cart went from the front of the blue cart and went all the way back here to this and then bounced off. And the red cart has barely gone this far, you know, just a little tiny bit. All right, now let's watch the scrolls. Now pay attention to the top of the screen here. So he stops it, and see, he just scrolled it. Now, why wouldn't he have the chart centered to start with, right? You got to say, what, he couldn't figure this out. You know, why wasn't the chart in the right position to start with? You know you're going to have more velocity this way than you're going to have bounce back velocity, so it should have been set already. But what is this aberration? What is this little green crap up here? It shouldn't be there. So I would argue that what the real mark was up here, and that this is an artifact, this down here. It's an artifact. It shouldn't be there. Okay, the computer did it because it thought that's what they wanted. And then this line is now all distorted because now it's gone higher because 0 is now here. The 0 line is here. So the whole thing's been thrown off by the fact that he didn't have the chart in a position where it could get to the maximum without going off the screen. And he did that on purpose, is my accusation. Why would he have it set up wrong like that? He knows better. He knows how fast he's pushing the cart. Come on, he's done this already. Why would he have to scroll the chart? So he already knew it does this defect. He already knew this is a way of making this velocity go way down and make this velocity look much higher. And that's the way to do it. That's the way to rig the experiment so it matches what the book says. Okay, and that's all these guys are trying to do, is match what the book says. They're not doing science. All right, so I say shenanigans, and he's been caught. Okay, so now let's get to the other one. The other one is so bad, that I mean, I really shouldn't be the person to catch this stuff. Somebody else should care. All right, but I have to get an image, so that'll take me a minute. All right, so the second video is all in French, okay, but it's just this basic experiment. 1 mass into a 2 mass, all right, and then you're just measuring the results. And so what you can notice right away, I noticed right away, why are these scale lines completely different? This has a little tiny, this is one cart, red cart, this is blue cart. Look, big giant squares, right? Big giant squares here, little tiny squares here. Why is that? Okay, and so then when you blow it up, I don't know if you can quite see it. I don't really want to get too big here, but we'll try. See if we can zoom it up a little more. You might be able to read the numbers, but these are in 100. This is 0.2, 0.02, 0.04. The scale down here, 0.1, 0.2. Okay, that's why they did it. So this scale is way exaggerated. So 0.2 is way down here. Here's 0.2. On the other scale, that's 0.4. So on this scale, right, on the lower scale, right, here's 0.2 here. This line is 0.2. Right here, this line, 0.2. Way down here. That line there. On this scale, okay, so I have to move this up. On this scale, that's 0.2, okay, right there. Okay, no, right here, okay. That's 0.2. So you get it, get how exaggerated this is. So this looks huge, I mean this looks huge when it's only 0.2. So 0.2 would be this line here, okay, here. All right, so let me move this over so you can see the two side by side. All right, and I'll make it a little smaller, I guess. All right, so I'm just saying the scale is way off. So one of them looks like it's a huge amount. Because, oh, look at the giant dip in the chart. Wow, huge, huge, huge. So down means higher velocity in this case. Velocity in the same direction. All right, so the first cart starts off, and then it is going to hit here, and this is where it changes direction, and this is where the second cart goes. Now this is 0.2, so the whole thing here is 0.2. All right, that's 0.2 right there. This is 0.4 on this chart. So this is 4 going in, and there was only 2 velocity coming out. All right, so just understand the huge cheat here. So they made this line look like it was bigger than a 4. Okay, right? This line looks like it's longer than this line. This height, the starting velocity. This line looks like it's longer than this starting line when it's actually half the height. It's only 0.2 here. 0.2, So that's the big deception. This is 0.2 here. This is 0.2 on this chart. So in fact, it's very close to what it should be, which is half the velocity. This is actually one half the velocity that this started with. So it starts off with a little better than 0.4, and it finished with 0.2 in the second cart. So the second cart, the twice as massive cart, actually has half the velocity. So just demonstrating shenanigans, right? Why do these charts have 2 different scales? Why? Why would somebody do that? Why would anybody who wants to do the experiment and show honest results, why would they change the scale of the 2 carts' velocities? Why would they do that? Okay, obviously, shenanigans. All right. So this is the stuff he keeps pushing. The Dispar keeps pushing these marginal frickin' experiments where we really don't get to see anything, we're really not seeing it done clinically and carefully, and he just keeps promoting this as good evidence that this is why you should believe. All right, and this is why I, okay, should somehow change my mind because of this crappy experimental data that's obviously been rigged. I mean, this is just a rig. You can't call it anything. Why would you do this? Why would a scientist change the scale of the image of the velocity? Why would you show the two? It's like showing one thing, with the camera and showing it this big, and then showing the second cart this big. It's like such a clear distortion, a clear deception. All right. So enough said. It's just more evidence that these people don't care about the truth. They don't care about the science. They don't care about the integrity of the science. They just care to propagandize for a religion, a dogmatic statement they insist people must believe. We must believe in their Jesus. Now, they claim Jesus can walk on water, but they won't take a video of that. They claim it takes 25 times the fuel to go 5 times faster, but they won't show us that. Okay. Instead, they'll do this. They'll play little rickety cart games, and distort the perception of the evidence. So they'll either cheat overtly, like Lewin and his clay blobs, or they'll cheat in all these little ways to deceive. Because it doesn't work, and they're forcing it to. And it's just so obvious. And the fact that none of you people will call foul. I mean, I was just talking about the Veritasium video in the last, where he did the single photon nonsense. And he tried to do the experiment as a time exposure experiment. That is, he tried to do it over a 4-hour period, and he couldn't get it to work. And the only way you get the experiment to work is he had to flood the experiment with photons. It's so obvious that, it didn't work the right way, so you do it the wrong way and force it to work. And then make up a story about how, it didn't really change anything, when, of course, it changed everything. All right, enough of a video. Really, this is just, you people are pathetic. You can't admit this isn't good enough evidence. This crap, this change the scale of the viewer, change the scale so it looks completely different than it actually is. That's good science in your book?